So this is the arrangement. There is a rod which is hinged at point A, and L by 4 length is on the left side and rest of the length on the right side of this point A. And here also it is with the help of a string we have attached it to the ceiling. So now it is asked that if this support or this string is cut, what is going to be the acceleration of end B. Okay, so it is asking the tangential acceleration. Okay, what is the acceleration of point B. Okay, so now as soon as we cut this, so we are going to get an angular acceleration. So angular acceleration is related by this relation, torque is equals to I alpha. Okay, so the only force which is going to provide the torque here is mg. Now about which point we are calculating torque. So if we are calculating torque, we have to first mark the point about which we are going to calculate the torque and moment of inertia. So we are using this point A, because if we use this point A, the torque of hinge forces which will also act is going to be 0. So our calculation will be easy. So the only force then left is this mg. So now if I calculate the torque of this mg, it is going to be L by 4. That is the distance of this line of action of force from this point A, that is L by 4. This is length L by 2, this is L by 4, this is L by 4 into mg is equals to I alpha. Now I, that is the moment of inertia, we have to find about this point, about the point which we have find the torque. Okay, so we are going to use the parallel axis theorem. What is parallel axis theorem? That moment of inertia about center of mass plus the mass of system plus distance, this distance between the point which we want to calculate and center of mass, is equals to I moment of inertia about that point. So in this case that point is A. So how are we going to calculate? So we know the center of mass moment of inertia is ml square by 12 plus m L square by 16, that is this distance is L square L by 4, so L square by 16 is equals to IA. So the value comes out to be 7 by 48 ml square. Okay, so from here what we can do is we are going to put this result in this equation. So L by 4 mg is equals to I 7 by 48 ml square into alpha. Okay, from here we get alpha calculation we will do, and alpha will come out to be 12g by 7l. Okay, so now we have to find what? Tangential acceleration. Now tangential acceleration and alpha, that is the angular acceleration, are related by this relation. So A tangential is equals to alpha r. R is the distance from the hinge about which it is rotating. So what is this distance from here? That is L by 2. This distance is L by 2 plus this distance is L by 4. So the total distance come out to be 3L by 4. Now we are going to put this in that relation. AT is equals to alpha r. Put this value of r, you get angular acceleration 9g by 7.